Hi, in this video we turn our attention to perfect square trinomials. So what is a perfect square trinomial? Well, a perfect square trinomial is one that results from the expansion of a perfect square binomial. So here we have a perfect square binomial. Two terms, quantity raised to the second power. So how does this expand? Well, it's x squared plus 2 times x times 7, which gives us 14x, plus this squared, which is 49. And here we have another perfect square binomial, x minus 3 quantity squared. So this then is the first term squared, x squared, minus 2 times 3 times x, which is minus 6x, plus 3 squared, which is 9. Notice it's minus 3 times minus 3 squared, which gives us 9. So given a perfect square binomial, it's easy to get the corresponding perfect square trinomial. What we are attempting to do in this lesson is go from having a perfect square trinomial to the corresponding perfect square binomial. In other words, given x squared plus 14x plus 49, obtain x plus 7 quantity squared. Okay, so let's look at the general pattern. Here we have a perfect square binomial, a plus b squared, and we also have a minus b squared. And if we expand this, we get a squared plus 2 times a times b plus b squared. Likewise, over here we get a squared minus 2 times a times b plus b squared. So what we want to see are the characteristics of a perfect square trinomial. So these are perfect square trinomials. They result from expanding perfect square binomials. So a perfect square trinomial, look at both of these. The first term is a perfect square. It's something squared, some a squared. Remember, a and b will eventually be replaced by more complex expressions. But whatever that expression may be, it needs to be a perfect square. So the first term here is a perfect square. The last term here is a perfect square, b squared. And the middle term is twice the product of the square root of a squared, which is a, and the square root of b squared, which is b. So that's the pattern. Whenever you look at a trinomial, the first term needs to be a perfect square, the last term needs to be a perfect square, and the middle term needs to be plus or minus twice the product of the square roots of the first and last terms. So remember, the square root of a squared is a, the square root of b squared is b. So let's look at some examples now. So is the first term here a perfect square? Yes. So we can write that simply as y squared. And then is the last term a perfect square? Yes. We can write that as 5 squared. And what about this middle term here? Is this middle term 2 times y times 5? Yes, obviously. That's 2 times y times 5, which obviously is 10y. Another way to look at this is to say, well, looking at this expression, it's like the a is y, the b is 5, and 2ab then is 10y. So this is a perfect square, and it factorizes as a plus b quantity squared. So that's y plus 5 quantity squared. So we have factorized this one. In this case, this pattern looks like this one, and so the first term squared is w squared. So the first term is w squared, so that means it's like, or a is w, or b, well, is the last term a perfect square? Yes, and so the square root of it is t. And let's check what is 2ab. 2ab is 2wt, 2 times w times t, which is what we have here. So this is a perfect square and factorizes then as simply a minus b, which is w minus t quantity squared. So we have factorized this one. Let's move on to this one. Is this a perfect square? Well, is the first term a perfect square? Yes. So it's like a is x. Is this a perfect square? Yes, it's 2 squared, so, or b then is 2. And let's see what 2ab is. 2ab then would simply be 2 times x times 2, which is 4x. And that is what we have here. So this is a perfect square. First term is squared, the last term is squared. Let me say that again. The first term is a perfect square, the last term is a perfect square, and the middle term is twice the square root of the first term and the last term. 2 times x times 4. So then this factorizes out then as a plus b, which is x plus 2 quantity squared. So you can expand this back and see that you get this, right? It's going to be the first term squared, x squared, 2 times x times 2, which is 4x, and the last term squared, 4. And finally here, we need to check first, is this a perfect square? It looks like this pattern here, so let's check. Is the first term a perfect square? Yes. Our a squared is like 4x quantity squared, so our a is then 4x. The b squared is 3y quantity squared. That's 9y squared. And of course then the corresponding b is just 3y. So let's check and see what is 2ay. 2ab rather, is 2 times 4x times 3y, which gives us 2 4s 8 times 3, 24xy. Is that what we have here? Yes. So all of this implies then that we can factorize this as a minus b squared, which is 4x minus 3y quantity squared. And so we have factorized this last expression. Okay, so thanks for watching this video. See you in the next one.